Hey guys, Mr. Newton here, bringing you a little chemistry help, especially with dimensional analysis. Now, keep in mind that this dimensional analysis stuff, this is the bee's knees of chemistry. This is the bedrock. This is the foundation. You gotta know how to do this stuff. So what I decided to do was make you guys a couple of videos here where I am basically gonna go through and show you how to do some of the assigned problems that you guys need to be doing at home. So let's get right to it. All right, if we take a look here, this is, oh, that's my Spotify stuff. Okay, here we are. Okay, so this is one of the problems that you guys might have. It says, how many molecules are in 1.123 times 10 to the fourth grams of O2 gas? Okay, now, and then there's a grid there that's all set up. Now, one of the things that's really, really important is that you identify the starting point and the finish point. So the start point is always a little bit harder than the end point. The end point is the question. So it'll say how many, how much. And so that always points to what you put on the last spot right there. So let's go back to the question, and we should be able to see that real quick. Okay, so if I look at that question right there, it says how many molecules. So molecules is my endpoint. So if I'm looking at that letter C right there, letter C right here, this is where I'm going to put that. So I'm going to go ahead and start doing that. So let's go ahead and make up this grid, and I'll put these things in place. So now I already set up the grid for you, showing you that you would need that many. So all these dimensional analysis problems have this grid, and then over here in the end is where you put your endpoint, molecules of O2, okay? So that's, that's going to be your endpoint. All right, so now where do I start? Okay, so if I look at how many molecules are in 1.12, so I get this measured unit, right? So that's where I'm going to start. That's the amount that I know that I want to convert to molecules of O2 gas. So you always start with this amount that you are given that is a known quantity. All right, so let's go back to it. So we're going to have let me write this down before I lose the view, 1.123 times 10 to the fourth grams of O2. Okay, so let's go back to working this out. So I have 1.123 grams of O2 gas. Okay, and then I need to convert that to molecules of O2 gas. So now what I'm going to do is I'm going to take my units, not my numbers, just my units, and I'm going to bring them down here, you see. And so you're always going to do that. You're going to bring whatever unit is right here down here. Now I got to figure out what can I convert grams to, and then I can convert that to molecules of O2. So there has to be a logical progression of I can convert grams to this and then that to that. So let's go back to the question, and let's find that plan or that progression. So I need to get to molecules. So if I look down here at my conversion units, these are all conversion units. It says that 1 mole of anything is this many molecules. So I know I can convert moles to molecules, but I'm not starting with moles, I'm starting with grams. So I need to convert grams to moles, and then I can get to molecules. So let's take a look. Here we go, right here. So if I look at this right here, I have 32 grams of O2 is 1 mole, and then 1 mole is this many molecules. So those are my conversion units. So what I find is that I can go from grams of O2 to moles of O2, you see. And what it said was, and then moles can go to molecules. So this is a progression where in between each of these steps on top, I have a conversion unit. I know that I can turn this into this, and I can turn this into this because I have those conversion units. And once again, I'm going to take this unit down here. Okay? Now the next bit of the process is just to fill in each of these. So I want to fill in each of my conversion units. So I'm going to go back and I'm going to look at Okay, how do I fill this in? I have grams of O2 and moles of O2. So let's go back to the chart right here, and it says that it's 32 grams of O2 equals 1 mole. Okay, so there you go. So that means 32 grams of O2 equals 1 mole. Now these always have to equal each other. Whenever you're filling in these conversion units, they always equal each other. They have to be exactly the same. So 1 mole is exactly 32 grams of O2. Now if I look at my, my chart again for this other one over here, let's go ahead and look at that chart. It tells me that 1 mole of anything is 6.02 times 10 to the 23rd molecules. So now I can fill that in right there. So let's go back and fill that. So 6.02 times 10 to the 23rd molecules of O2 is 1 mole. So whenever you're looking at those conversion units, you know, they can be on the top or the bottom. They can switch places. Where they are is determined by this right here. You have to pull this unit down, because what you really want to do is you want to cancel these units. So when I cancel these, when I divide these out, I end up with this unit as my last one. So now my job is to multiply the top and divide by the bottom. So going back to our calculator skills, which I will tell you that when students get this wrong, 95% of the time, it's because of the calculator problem. Okay, so if you set this up right, all you got to do is type this into your calculator right. So I'm going to start here. I'm going to go 1.123, and then what I'm going to do is I'm going to go second EE on this one. Whatever it is, you want to use that EE function. I would encourage you guys to get these Texas Instruments. They make it easy. So second EE 4. So when I write that on my calculator, this E4 means times 10 to the 4th, okay? And now I'm going to continue to multiply. So I'm going to just do all my multiplication across the top. So I'm going to go times 6.02 times 10 to the 23rd. So I typed that into my calculator correctly. So not typing things into your calculator correctly, or using calculators that aren't able to do the scientific notation, is oftentimes what gets wrong. So when I do these, I set this up, I multiply across the top, and then I divide on the bottom. So divided by 32. So I have 1 divided by, over here I just have 1, so it doesn't matter. I'm going to press enter. My calculator shows me this big huge number. What do I round to? And so we talked about rounding rules. Now the nice thing about dimensional analysis is this first measured unit determines the number of sig figs, okay? And this has 4 sig figs. We don't use these conversion units for sig figs because conversion units have an infinite number of sig figs. They're measured out to what we would consider perfection, I guess. But anyways, the whole point is that you don't use conversion units when you're calculating your sig figs. You only use the measured unit. So this is the one measured unit is right here in the start point. And that has 4 sig figs. So if I look at my answer right here, I have to round to 4 sig figs. So this number right here needs to be rounded, and it's going to be rounded up. So I'm going to write that out. I've got 2.113 times 10 to the 26, or if I'm typing it into my computer, 2.113 E26, just like the calculator says it right there. So there's my answer, and I want to put my unit, molecules of O2. Now I know in the computer, oftentimes the unit is written out for you, so you don't need to write that in. You just write in the number, but this has the correct number of sig figs. It's also the correct answer. So there you are right there, and that is the correct answer for that one. So if I was doing this right here, I would say, what goes in blank A? Well, it's going to be the answer right here, G. G is going to go in blank A. So, you know, I'd put in G. So that's what I put in blank A. What goes in blank B was 1 mole. So that is going to be E. what goes in blank C. So blank C up there was the number of molecules of O2, the 6.02 times 10 to the 23rd molecule, so that's going to be C. And now I'm going down here. There was nothing in blank D, so I can put a 1 in there as a placeholder. What goes in blank E? Blank E, if I look at my paper, was 32, and then go back to the paper here when you guys are seeing this. So we're right here. We're just plugging these pieces in. So once you fill this all in, you can just match it up and plug those guys in. So blank E was 32 grams. It's right there. So that's going to be F. And then the last one, blank F, looking back at my thing, that was 1 mole of O2. This was 1 mole of O2. So I'm going to go back here and I'm going to put the same answer, E, right there. So that's okay if that's twice. So that's perfectly fine. And then for the last one, what is the correct answer with sig figs? Well, the correct answer with sig figs, we remember, was rounded to the 4th. And remember, we rounded that 2 up to a 3. So the correct answer is actually D right there. So they give this one that wasn't rounded correctly, and then this one is. So there you go. There's an example of how to do one of your homework problems. Hopefully that helps you guys out. We're going to have a lot of those this week, and if you guys need any help, feel free to contact me, and I'd love to walk you through these. We got to make sure to get this dimensional analysis. Super important for chemistry. You guys are doing a great job. Take care.